Hello everybody, it is me. It is time we do stream again, cause we rock and roll, we vibe and go. Here, let me play this. Let me turn this down just a touch. There we are. Awesome. Anyways, yeah. Hi, how's it going? I'm assuming we're live now. If we're not live, that'd be very cringe. Oh, we are live. Yay! Look at that. Yeah, so I just want to bang through another Vulkan chapter. That's the TLDR of this stream. Don't want to waste too much time. I want to get right into it. So, this is my working file. And yeah, we're just going to chip through it. So, I'm curious. Let's do a quick set RNU. How deep are we? I should do a quick count. Sorry, one second. I gotta remember an nvim command. Nvim show current line with RNU. Let's see. Okay, there we are. So it's set number relative number. BAP 314. Neat. 314 lines deep. So yeah, so I guess I'll share kind of my little feels and vibes right now. So overall I'm decently rocking with the with the stream and the vibes and the whatever, right? My current sort of gripe, issue, whatever you want to call it, is that I'm feeling a bit lost in the sauce now, right? I think it's gonna be one of those things where I'll get a lot more of it with like repetition, right? Because as it is right now, you know, it's like I don't understand everything. I'm still dipping my toes, and I kind of did the idea of like, okay, we're knitting with GLFW, then, you know, we're getting like the queue process is ready and whatever, right? I forget what the main loop is, actually. That I don't have any recall of. Let's see, main loop. So the main loop, I wanted to go to that, actually. There we are. Okay, so the main loop is just basically making sure that GLFW isn't closed. So it is literally just main, effectively. Okay, that makes sense enough. And then, so GLFW then pull events. Let's go to the definition of that. Can I cycle? Oh, there's no cycle there. Oh, I don't really know what to do about you. And then, because our entry point is main, let's see what main is rocking with us. So, main is literally just hello triangle app. I don't understand what this is doing here. I actually just don't understand what that is, so I'm going to toss that into an LLM. And we will see, Let's see. Okay, so now that we're here, I just need to explain this because I don't understand this, and I don't think it would be an easy search. So I'm just gonna bounce it off of R1. Let's see. In my C++ program, the first line of C++ in the main function has the line. Hello triangle application app. What does this mean? Question mark. Let's see. So into the main function means that you're creating an instance of object of the class hello triangle named app. What's wrong here? Hello Triangle application is a class. Oh, okay. So is that the issue? Because yeah. Because there is the Hello Triangle app thing up here, right? Like that's the whole class definition. Now that it brings that up. Yeah. Okay. I don't want to name that application. I just want to name this Hello Triangle class because that just makes it a lot easier for me. Because not having it be that just confuses me. Hello Triangle class. Because that just makes a lot more sense to me. I know it isn't one-to-one, but having it defined as a class instead of an application just makes so much more sense. Yeah. That helps clear things up infinitely. I don't know what I was thinking there before, but that helps a significant amount. Yeah, so that's just instantiating the program, basically. Then the constructor does its thing and starts running all of its magical garbly-gook, right? So that tracks, that adds up. Let me make sure this is over here. I'm going to turn my music up just slightly because it's a little bit hard to hear. There we are. There we are. Awesome. Yeah, and then outside that, let's see. Then we're going main loop. Which is here, and then cleanup makes sense because cleanup is getting rid of everything. So I'll have to go into this more thoroughly, but yeah. So what I think I'll do this time is I think I'll go through this like once over, because it should be the new page that we're on. I think, I hope, I pray. Logical device and queues. Yeah, that sounds about like where we were. I didn't change the tab, so I think that's about right. And then after I do that, like I give it a read, then we'll go through it again to give it like an implementation phase, because hopefully that'll give me a bit of an overview, because right now I feel like I'm not quite catching everything, so I want to kind of feel like I think going over it pseudo twice would be nice. So let's see. So introduction: after selecting a physical device to use, we need to set up a logical device to interface with it. The logical device creation process is similar to the instance creation process and describes the features we want to use. We also need to specify which queues to create now that we have queried which queue families are available. You can even create multiple logical devices for the same physical device if you have varying requirements. Start by adding a new class member to store a logical device handle in. So VK device, okay. Next, add create logical device function that is called from init vulkan, create logical device. Okay, so I'll just put that here. Or I'll look for init vulkan. I know what I just said, but I just want to kind of put this here as a comment. Oh, we already have that. Nice. And then yeah, the function of create logical device. Specifying the queues to be created. The creation of the logical device involves specifying a bunch of details in structs again. Of which the first one will be VK device queue create info. This structure describes the number of queues that we want for a single queue family. Right now we are only interested in a queue with graphics capabilities. So I opened you in a new tab. So what's this? C specification. So type def struct VK queue creation info. Structure type S type const void p next. I don't know what p next means. VK device queue creator flags UN32 queue family index UN32 queue count. Const float that points to PQ priorities. Okay, that tracks enough. That doesn't give me a ton of information, but I can grind with it. I can deal with the fuzz. Specifying the queues created. The creation of a logical device involves specifying a bunch of details in the structs again, of which the first one will be VK device. Oh yeah, we did that one already. So then it's queue family indices equals queue family indices physical device. Okay, so basically we're getting the type of queue families we can get from the physical device. We are then basically it says device queue create info. I'm guessing this is like basically like initializing the class that like we just read about right here. After we do that, we're basically setting the S type. I don't know what S type is supposed to be. I'll probably open this again to have a glance at the S type. So the S type is, what is it supposed to be? The S type is a VK structure type evaluated defining the structure. Okay, pnext is a null or pointer to a structure extending the structure. Okay, so it's kind of like a linked list is what pnext is basically. Okay, maybe not exactly that, but it sounds close to it. Let's see, queue create info, queue family index, indices.graphics family.value. So basically, we're just trying to find which index the, my guess is that the graphics family lives in. And then queue create info, queue count 1. So I'm guessing this is to create a single queue to like render triangle is my guess. The currently available drivers will only show you how to create a small number of queues for each queue device family. You don't really need more than one. That's because you can create all of the command buffers in multiple threads and then submit them all at once in the main thread with a single low overhead call. Vulkan lets you assign priorities to queues to influence the scheduling of a command buffer, executing using floating point numbers between 0 and 1. This is required even if there's only a single queue. Yeah, so float queue priority 1. So my guess would, if I had to guess what you could do with this is, in a game sense, you could probably assign different, like, objects to like different Q values, right? So my guess would be is like, you could set like a character in world to be like, say like 1, right? And then you could set, say, like, like particle effects to be like, like 0.3 or something low, right? Where like this isn't very necessary. It'd be still nice to render, but not like necessary, right? Because like, like if like a dust particle doesn't get rendered that frame, as long as it's not flickering, it's not like, urgent, right? So I can see that being used like that. Create info PQ priorities, which is the address of Q priority. So yeah, so we're basically just setting that to this. So I guess I could just also just shred this and then just also assign that to a strict float, but that seems like it might be just a pain. So it's like I think it's separating more values in RAM, but I don't think that'd be a big deal. Specifying use device features. The next information to specify is the set of the device features that we'll be using. These are features that we create support for with VK get physical device features. Oh, here's my headphone cable is like, it has like a bad, like, okay, so mine's like a hybrid cable where like it's half curled, half not. I respectfully disagree with DankPaws, and I just realized there's a part of it which isn't curled properly, and I don't like that. Okay, there we go. I think it has been fixed. Huzzah! Huzzah! All right, let's see. So, VK get physical device features is in the previous chapter. Sorry, in the now that we created for support with VK get physical device features in the previous chapter, like geometry shaders, right now we don't need anything special, so we can simply define and leave everything else to VK false. We'll come back to the structure once we're going to start doing more interesting things with Vulkan. VK physical device features. Yeah, so you're calling the VK physical device features a class, and then you're instantiating a new version of it. Let's see, creating a logical device with the previous 2 structures in place. We can start filling the main VK device create info structure, VK device create info, create info.sType, VK structure type device create info. So again, this isn't very verbose, but like taking a second to like think about it is like, it's like saying like, hey, VK structure type is going to be the type of device, and then what device, or like what are we doing with the device we're creating the info. I can read it, I think, if I'm reading it correctly. It just feels ganky, First add pointers to the Q creation info and device features structs, create info dot PQ and create info, and yeah, there's that Q create info count 1, create info dot P enabled features is equal to the device features. The remainder of this information bears a resemblance to the VK instance create info struct and requires you to specify the extensions and validation layers. The difference is that these are device specific this time. Okay, wait, so the remainder of the information bears a resemblance to the VK instance create info struct and only requires you specify extensions and validation layers. The difference is that these are device specific this time. Okay, so what it's basically saying is that like there's not like a global thing. I got to do like the VK Chronos swap chain thing like they do there. An example of the device specific extension is the VK Chronos swap chain. Yeah, it's pretty much called it, which allows you to present rendered images from a device to Windows. It's possible that there are Vulkan devices in the system that lack this ability, for example, because they can only support computer operations. We'll come back to this extension in the swap chain chapter. Previous implementations of Vulkan made a distinction between instance and device between instance and device specific validation layers, but this is no longer the case. This means that the enabled layer count and PP enabled layer names fields of VK device create info are ignored by up-to-date implementations. However, it is still a good idea to set them anyways to be compatible with older implementations. So if enabled validation layers, then you're enabling a layer count with a static cast. I'm guessing that's a... I'm going to look up what that is, because I actually don't know what that is. I'm not very deep in the whole C++ world, so I actually can't say. Static cast C++. Static cast conversion. Static cast... I don't want to read the AI. I'm not reading the AI. Explanation. One of the following conversions can be done with static cast, except such conversions cast away costness or volatility. If an expression is an I value of type CV1 base and the target type is referenced to CV2 derived, the result refers to the object of type deriving the enclosing expression if all conditions are satisfied. Class version is complete class type. Base is a base class of derived. C1 is not greater than CV qualification than CV2. Okay. So I honestly don't understand this, so maybe that's a bad example. is a urinary operator, which fuck off Google, which forces one data type to be converted to another data type. Supports 4 types of casting: static, dynamic, const, and reinterpret. Static casting, simple type. Okay, yeah. So is it like I can assign something to float, and then okay, yeah. So it is a conversion. I can see it being used here. It's basically static cast the type, and then move on from there. Got it. Following. Whoops, that's not where I want to be. I don't think. Where the hell did I go? Here we are. Yeah, so static cast, UN32 type, validation layers size, create info, pp.enable layer names, validation layer, else create layer count 0. Let's see, we won't need any device specific extensions for now. That's it. We're ready to create the instance of the logical device with a call to with call to the appropriately named VK create device function. If VK create device physical device, the address of create info, a null pointer, and the address of device is not equal to VK success, then throw an error. Let's see. The parameters are the physical device to. The parameters are the physical device to interface with. The queue and usage info we just specified. The optional allocation callbacks pointer to a variable to store the logical device handling in. Similarly, the instance creation function called assign return errors based on enabling non-existent extensions or specifying the desired usage of unsupported features. The device should be supported in cleanup with VK destroy device function. Cleanup VK destroy device and null pointer. Okay. Okay. Let's see. Logical devices don't directly interact with instances, which is why it is not needed as a parameter. Okay. Retrieving queue handles. The queue handles are automatically created along with the logical device, but we don't have a handle to interface with them yet. First, add a class member to store the handle to the graphics queue. VK queue, graphics queue. Ooh, we're finally getting to the point of the graphics queue. Let's go. Device queues are implicitly cleaned up with when the device is destroyed, so we don't need to do anything in cleanup. We can use the VK get device queue function to retrieve queue handles for each queue family. The parameters are the logical device, queue family, queue index, and a pointer to the variable to stop the queue to store the queue handle in. Because we're only creating a single queue from this family, we'll simply use the index 0. Okay. So my guess would be like if you have like a lot of like shaders or something you're trying to process at once, you can use this to like offset and separate them all and stuff. So that kind of makes sense. With the logical device and queue handles, we can now actually start using the graphics card to do things. In the next chapter, we'll set up resources to represent the results in the Windows system. Okay. So what I'll do quickly is I'll attempt to implement this now because we read through that part, right? And we'll kind of carry on from there. So let's see. So it's saying I need to then create a device. So within the class, I will create, I guess, a private VK instance. I guess I'll do a new one here, which is going to be VK device. And I'll do a quick sniff test against like the comparison file, right? So then next is going to be in init vulkan. We're going to add the create logical device, which is right here. Let's see. I corrected all of this, so this can all be gone now. So then we're doing this somewhere else. I'll move it to be more compliant later. I just want to, get it out now. Create logical device. And then inside here, we're going to be doing a lot of work. So let's see. Specifying the keys to be created. Okay, so inside here, we're then going to do queue family indices. Indices is equal to find queue families. And then we're doing the physical device. I need to fix that. There we are. Value indices not used. That's fine. And then after that, we're doing VK device queue create. Queue create info. Queue create. Oh my god! I keep mistyping the C. Create info. There we are. Unused variable, I don't care. Queue create info. dot s type is equal to vk underscore structure underscore type underscore device underscore q underscore create underscore info. Oh, I misspelled types, so let's go back to here. We'll fix that PE. There we are. Whoops, I don't mean to do that. And then we'll do Q create info.
I keep doing a V.
Create info dot Q family index is going to be equal to indices dot graphics family dot value. And then we're also going to do Q create info dot Q count. Count, I say, that's going to be equal to 1. Awesome. So now we have Q count 1. What's going on here? Oh, shoot, I accidentally double type space. There we go. Okay, now that we got that, then we're going to set the Q priority. So then we're going to go, float. Oh my gosh, float. Q priority is equal to 1.0f. That's a frickin' slash, my fingies. Let's see. Q create info dot pq priorities is going to be equal to the address of Q or the value of Q priority. I spelled priority very wrong, I think. I also expected that. That's also spelled wrong. God, I'm typing so sloppy right now. Yep. Okay, they were fixed. Awesome. Okay, so then after that, specifying device features. So yeah, so then we're gonna go physical device features. So let's see. Let's go here, I guess, which is gonna be like set Q. Actually, that's kind of self-explanatory. I don't really need to add a comment for that. And then here we're just gonna say, hey, so let's see. We're gonna go VK physical device features. Device features. That's the wrong type of brackets. There we are. I did a capital H again. Whoopsies. There we are. Okay, that's unused because then down here we're going to do VK device create info create info. I spelled that wrong again. I think this is supposed to be higher. I think these are in the wrong spots here. So I'm just going to do that. I think these are in the wrong spot. So this will be a call to myself in the future. And then after that, we're going to do create info dot p q create create infos is equal to the address of Q create info. And then after that, I don't know why, whenever I save it seems to jump down 2 lines, whatever. Create info dot Q create info count equals 1. Let's just fix that. And then, let's see, create info dot P enable features is equal to the address of device features. I spelled features wrong. U or yes. P enable features. No member name P enable features. What is the error I'm getting right now? Because it's very hard to read. Oh, I can do a Lua thing. Volb, I don't see the so-called triangle I was promised /J. Well, you see, Holy, I am suffering right now. You see, this is a multi-part stream to build towards the magical Dorito. That's basically it. VK device, create info, do you mean P enabled features? Did I spell it wrong? No, it says device features. Info.p enabled features, and the address of device features. FEATUR, yes. Okay. P enabled features. I'm just gonna go, Really, when aren't you suffering? When I die. When I'm dead is when I will stop. That is when the suffering will cease. Nah, I mean, I don't actually hate it that much, right? It's frustrating to learn, but once you have the knowledge, right? And we'll have to see what happens once I have that knowledge. So we'll have to see. So, hey, here's the suffering, I guess. Anyways, how you doing, Holy? You're doing well. Been a hot minute since we chatted and said hi and whatever the heck. So yeah, how you doing? Let's see. Create info dot enabled extension count is going to be equal to 0. So let's see. So all this is for legacy support. So we're doing legacy support now, which is going to be thing, which is going to be here. I'll do 3, and then we'll end the legacy support with 3, end the legacy support. Oh my gosh, I keep typing so bad right now. You're good to see you right now. I thought I would stop by since I'm not up too much. That's totally fair. I mean, hey, thanks for swinging by. We actually have to slam through that, the rest of that Super Mario 64 at some point. Because I still have that just eating away at the back of my brain because I got that type of tism. Let's see. Obviously, no pressure for, when or whatever. I'm just more like, oh yeah, we haven't done that yet, you know? What you eating? The food good? Let's see. So then we're just going to go, if, something happens, then I want to do the thing. The thing that I want to be is if enable validation layers. Then I want to do, hey, guess what? We're doing, say, whoa, no, that's the wrong line. We're doing, say, hey, create info dot enabled layer count is going to be equal to static underscore cast. My guess is that by default, why we have to do a static cast is because by default it just stores itself as an int. So my guess is that the unt32 thing kind of fixes that somewhat. And I'll read your message in just a second. I'm just trying to finish this validation layers dot size. That's too big. Let's see. I think it's wrap none. No, what is it? It's a set wrap none. Frick, I don't remember what the command is. No wrap. Set no wrap. There we are. Got it. Found it. So that needs to just have a quick little thing on the end of it, and then we gotta do an else, and then I'll read the message here. Let's see. Yeah, hopefully soon. Just been doing school stuff and playing games. That's valid. I mean, hey, feel free to, DM me and say, hi to whenever you want to do it, because as long as you give me a couple days notice and, it isn't, what is it, Sunday to, Thursday, I'm generally pretty open. I can do it those days. It would just have to be, earlier, right? For something 6 to 12, because I think there's only be, 2 to 4 hours left of it, right? Consider I'm not trying to 100% it, but you get the idea. You eating chicken sandwiches, very yummy. Well, what's on it? You gotta share more deets than that. Come on, there's gotta be more than just chicken and bread. Come on, what's the deal? You got way too much mayo and it's spilling everywhere. What's happening? Give us the deets. Give us way too much information on your chicken sandwich. Let's see. Create info dot enabled layer count is equal to 0. God damn it, 2 E's. Why is my spelling so sloppy right now? Holy crap. And after that, whoops. So basically, if we're not worrying about that, then skip it. And then after that, if, let's see, vk create device, physical device. I'll read in just a second. Just trying to bam through this. Create info null pointer, the address of the device value, And if all that is, say, not equal to VK, I'm just going to enable caps lock for this, VK underscore success, then we throw an error, because I'm recognizing patterns now. Where is my cursor? What is Where is my cursor? What? Oh, should I have caps lock on? That's what's happening. Okay, let's undo some of that. Okay. Yeah, I think that... Okay, that's a little bit better. Okay. Okay, so I was like, 40 lines down. I don't know what the hell happened there. Well, I do know exactly what happened. I just was very thrown off. Device, and then let's just oh my god! And then we gotta go back here, new line it, and then, okay. Now we'll take a peek. Let's see, size, just an average amount of mayo with 2 patties on each sandwich and 2 tomato slices on each as well. I mean, fair enough. I mean, like, whatever works. Not gonna lie, I've been, like, low-key depressed about, like, not, like, having, like, good access to a kitchen right now, because, like, I've been watching, like, a lot of cooking channel, like shorts, I should say, not channels, shorts specifically, but I've been watching, like, a lot of cooking shorts recently, and I'm like, man, I can make so much bomb food, but, like, I just can't. So, like, I think I'm gonna turn my sort of, like, living situation into, like, a crock-pot kitchen, if that makes sense, and just kind of do that, because there's a lot of good things I know how to make with, like, a crock-pot. It's, like, slaps. Let's see, in Super Mario 64 stream coming down Friday, if nothing else comes up, of course. I mean, yeah, sure, I'll slot you in. We will commit publicly to this and make sure that you cannot escape. Yeah, not having access to the kitchen sucks. This food is provided from the shelters, so I was limited. No, that's completely reasonable. Yeah, like, for context is, I'm a person who doesn't like the half-ass stuff, right? The way that I see it with, like, food, right, is because you have to consume food so much. You should either not care at all and go for, like, a protein powder that is, like, your nutritional needs and, like, nothing else if you don't care about food, or you should go the other end and, like, just learn how to cook, because, like, like, cooking isn't that bad of a thing, right? And, like, obviously this isn't targeted at you or anybody. Like, I understand your scenario is different. So, like, don't let this sound like a call out, because it's definitely not intended to be that. But, like, like you'll see people who, like, their cooking prowess is like, oh yeah, like, my thing is that, like, I do like mac and cheese, a lot for me, and it's like, how have you not tried to do, like, more, like I'm not saying you need to be, like, insane, but it's like, like, have you not urged to, like, create food that's, like, better than McDonald's, oh my god, cause, like, how do I put this? Like McDonald's is fast food, right? So it's like, it's like, there shouldn't be, like McDonald's is fine within the proper context, right? The issue is that, like, if anybody tells me that, McDonald's is awesome or whatever, I'm going to immediately throw eyebrows. Like, if they say it's above, like, a 6 out of 10. 6-ish out of 10. You know what I mean? Does that make sense? Let's see, destroy device, and then we're just throwing in the device, and then the null pointer. Let's see. There we are. VK destroy device. Did I not create one named VK destroy device? Okay, I see. So, no, that's device Q. Let's see. Yeah, definitely someday I will train myself to do more than grilled cheese spaghetti and mac and cheese. It's honestly super easy. The main thing that I found that is like intriguing with food is just simply finding stuff that, like, works together right. Because, like, for ages I thought I hated food, and no, it turns out I just hated the way that, like, most people cook, right? Like, also, what do you mean McDonald's is an 8.5 out of 10? Shake my head. I mean, it depends the mental connections you have to it, right? Like, I don't have any strong mental connections to it. So for me, McDonald's is just like, okay, so, like, I'm just grabbing something and going, right? So, like, once, like, if you have no, like, strong mental, like positive emotional association with it, I think the association falls a lot, right? Because I definitely had a few instances where, like, as like a wee kidlet, I got sick a few times, and, like, oh, that was not fun. Let's see. So undeclared identifier, destroy device. Okay, I need to refer to Lua thing. Let's see. Lua. What's going on here? Do you mean VK destroy device? Is it lowercase? No, VK destroy. TROY. I keep doing the R before the frickin' before the O. Oopsies. There we go. Fix that. Yay. Alright, let's see. So then retrieving Q handles. So then we're gonna do VK device graphics queue. Okay, so I'm guessing this needs to go at the top of the thing towards here. So we'll do it like here. And then we'll do VK Q graphics Q. And then let's see. Yep. I personally haven't had any bad experience with McDonald's, so it's just reliable as much as any fast food could be, I guess. Yeah, I mean, like, my entire thing with it, to I guess, explain more thoroughly, is that it is generalist food that appeals to, like, the widest amount of people, right? So, like, it's not meant to be... It's not meant to be like a revolutionary graphics, or not graphics, a revolutionary flavor experience, right? It's not meant to be like be unique or interesting, right? Like the most they'll do is throw like 3 jalapenos on your fucking burger and be like, ooh, it's the new spicy edition, right? Like it's really, really inoffensive, right? And that's fine, but it's inoffensive, right? Like the reason why I say it's a 6 out of 10 food at best, maybe 7, is because, like, if you think of it like a scale, I'm gonna whip out Critter for 2 seconds, right? Because I want to, like, you know, pull this out, right? So it's like, if you go to create and then I orientate you upwards, there we are. So like, if like we think of a scale real quickly, right? So I'm gonna make this a little bit smaller. Let's go like here. Does that appear nice? Okay, cool. So like, if you have like a scale, right, where like, you know, it's like, so like here's the middle, so this would be like a 5, right? Then you have, I can't see my cursor right now. There it is. There we are. Ba-ba-da, ba-ba-da. So like this is like a 10, and then like this is like, you know, a 1, right? So then, you know, 1, 2, 3, 4. 1, 2, 3, 4. Good enough. Close enough, right? Like, my entire issue is that, like, McDonald's needs to sit, like, right here, right? Because that is where you'll get the most appeal. Because the minute you start going more over here, like this way, you're then also pushing a group of other people this way, right? Like McDonald's entire purpose is to appeal to the most people, right? So by making food more creative, expressive, flavorful, whatever, you are actually also alienating people, right? So this is where I'll put like the golden arches here, right? MC for McDonald's, right? So that's the idea, right? By comparison, I've eaten at like some fucking vegan restaurants where like they'll do like some really weird shit, like they'll put like a ton of nuts in like bread. I don't mean on the top, I mean like throughout the bread. And this is on like stuff like, you know, sandwich buns. Like there'll be nuts in your sandwich buns. And like for me, that shit like rests down here, right? But I'm sure for other people, you know, the vegan place sits like over here, right? So it's like, it's a similar thing where this is kind of where the whole thing goes, is that like I feel like I feel like the scale gets normalized, right? So like people who think like McDonald's slaps, I think the best way to think about it is that they've only experienced food to roughly here, right? And they haven't experienced much else past it, right? So the people who you know think McDonald's is the shit, or at least is like really up there, whatever. Same thing with like Five Guys and a bunch of other stuff. I don't think they've actually experienced that much food, right? And like, to be very clear, I'm not like a restaurateur who went to like $100 plus restaurants and, oh, it was an exquisite experience. I just mean like, you know, like you throw like some chicken, sour cream, butter, and like salsa in like a crock pot, let that shit cook, and that shit is like a creamy delight, right? Like it is exquisite. But then you just have a lot of other people who are just like, oh yeah, dude, like craft dinner is my shit, right? And it's like, yeah, you can't dislike craft dinner, but again, craft dinner, you know, sits like here, right? Like it's an inoffensive mac and cheese, right? Like that's the way that I see it. Call me spicy. Like I personally, as someone who doesn't work at KFC, like their with their food. Oh, sorry. Like I, as someone who oh my gosh, sorry, the chat jumped, so that messed with me. Okay, let's see. I'm gonna scroll a tiny bit. Oh no, I can't scroll because stupidity. Yeah, Kraft is below McDonald's. Yeah, this is not representative of the actual order. You know what? At some point, we should do like a food tier list stream. Just saying, like when I say we, I mean like everybody in like chat, right? Like we should totally do like a food tier stream where like we rank like general foods and just see how that goes. Anyways, trying to actually read Cody's message now. Like personally, I as someone who doesn't work at KFC with their food. It basically is the same things at our store. We have a few changes to food items, like fillets being changes from being cooked the same way as flours, tenders as the original recipe, to now the same as flours as zingers. And then we have some promos every now and then, like new KFC on the menu. Like the hot and I mean hot and spicy, and like yeah, that's exactly it, right? Like there's jokes about how like Taco Bell has like 5 ingredients, right? Where like Taco Bell's entire menu is like beef, cheese, lettuce, beans, and like various sauces, right? And then all that you see like Taco Bell ever do is just play with those in different ways, right? Like if we look up like a Taco Bell menu real quickly, right? Taco Bell. Taco Bell food. I'm just gonna look up food and go to images, right? Bluck, get out of here. But like, if you go here, right, like like here's the entire Taco Bell menu, and it's like, okay, so like a quesadilla is just chicken, cheese, hold the lettuce and other various vegetables, right? You look at like the gordita crunch. That's just a larger tortilla, like a large freaking tortilla shell. And then you just, fold it in on itself and put it in a press, like a panini press, instead of folding it into a burrito, right? Like, this shit is literally just a taco, but like a taco Hot Pocket, right? Like, it isn't different, right? And that's like what I mean, right? Hot and spicy were the same chicken as the original recipe, but the zinger flour. Yeah, so like yeah, exactly that, right? And like to be clear, like I'm not hating on fast food places for doing this and mixing it up. It's just again, this food is supposed to be generic, right? It is supposed to appeal to people, right? Like I'm not trying to hate on like this food existing. It's just that it's like it's just not amazing. I'll be real, I never had Taco Bell. More so I can't really stand burritos and tacos. I don't know why. You might have had some shitty ones, because do you like chili? As like a question, like I know this sounds kind of weird, but like, do you like kind of like a thicker chili, like not watery, like I'm talking like where it's almost like a paste? Do you enjoy that? Out of curiosity. Let's see. Chili. Like this would be an example of like kind of what I'm thinking. Dum 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 dum. Sorry, I'm being stupid. Let's see. I'll let you respond to that while I carry on. So we got the VK graphics queue now. Then we can use the VK get device function to retrieve the queue handles for each family. The parameter. Okay, so yeah, so VK do device queue. Okay, so this is going to be in the create logical device, I think. It varies depending on who cooks it. It's like in general. I know I do tend to be a bit picky eater half the time. Yeah, that's fair. The reason why I ask is because like if you like chili, a good taco is kind of like chili just in a shell, right? Like depending on who you ask. But that's a vast oversimplification of it, and like true taco connoisseurs will stab me for that, right? So like that isn't it, right? But it's an idea of it, right? So like it's one of those things, right, where so a lot of people will not understand like what a good like taco is, right? So like if you're experienced, this is putting it kind of like bluntly, but it's if we look at like white people taco, right? If you look at like white people taco, it's like if you have something like this isn't like necessarily an authentic taco. It's still good. I like these, but they're not like authentic, right? When if you look up like by comparison, like authentic taco, something like this, like you can see these are very different. So like these often use like a corn tortilla instead, right? You can see that the beef is cooked differently. Like it is a completely different experience from like what like the quote unquote white people taco is, right? I think a better way to put it would be like this is a traditional taco, and like this is like a commercialized, like an Americanized taco, right? And when I say American, I mean like, you know, like United States American, right? Or like Flanderized taco, or you know what I'm trying to say, right? Because like a great example is like, you know, like if you look at pizza, it's like this isn't pizza, this is like American pizza, right? Then if you look up like authentic pizza, like this is what authentic pizza is supposed to be, right? So it's a massive spectrum of stuff you can and can't enjoy, right? It's just down to, you know, preferences and a bunch of other stuff. Because like I thought I was a picky eater. Turns out I'm not. I just realized I don't like a lot of people's cooking, and I'm very picky of people's cooking, not of the ingredients, right? Because I've had some dog ass things. Like actually, here's a random side thing. I don't like runny eggs. I don't. I just flat out don't like them. I'm fine with soft eggs. I'm fine with, you know, like mostly cooked like eggs, stuff like that, right? My issue is like I don't like runny yolks. It's just something where like I can still eat it, to be clear. Like just this morning, you know, somebody made breakfast and like, hey, you want one? I'm like, fuck yeah. But like, you know, I did think less of the sandwich because it had a runny yolk, right? Like it just wasn't my preference. But like, there's also other things too, where like the yolk can swing the feel a lot, right? So like, for instance, that was on a sandwich. So for me, a runny yolk on a sandwich is like a huge like like it will lower a like sandwich for me by like a whole point, right? Whereas like if I'm having like an eggs Benny with hollandaise sauce and the yolk's runny there, I don't give a single shit because there's just sauce everywhere. It all just blends in, right? Everyone in my family loves runny eggs. I refuse to have runny yolk. Yeah, like I don't necessarily refuse it, like I was saying, but again, it's just like I do not prefer it, right? Like I firmly do not prefer it, and I think in effectively every circumstance except for one that I can think of, it is lesser. And the one where it's better is if you have a ramen and like you have like a bone broth, like, you know, egg. And like that egg has like a runny center, and like, you know, like you like pick up the egg and like it runs a little bit, and a little bit of that like yolk gets into your like soup broth. It kind of adds that umami-esque taste to like, not umami, but is it umami? I think it's umami. But like the umami savory taste to the ramen broth, which just adds a little bit to it, you know? Like it's not a ton, but I find it helps. It's subtle and it's just good when it happens, right? So, you know, bite me. Anyways, so now I gotta toss this in somewhere. What was the entire function we were just working on? Now that I've been utterly flashbanged. Okay, yeah, so we're like here-ish. So we'll do this. So this is for legacy support here. Boink. And then we'll do one more line, which is going to be VK get device Q. And then after that, we're going to be passing in the arguments of... Oh, that's a lot of arguments. There's going to be device, indices dot graphics family, family dot value, 0, and then the reference to the address of graphics Q. And that's the end of it. Cool. Alright, so now we gotta do a little bit of, like, reviewing on this, because I have no idea where anything is. But yeah, like, so this is actually a side thing, and this is something that might not everybody understand about me, but screw it, I'm gonna go for it anyways. Is that, like, I'm a person who likes to care, right? I like to care about people, I like to care about what I'm doing, I like to care about my food, right? Like, almost everything I will care about, right? That's just the thing I am. Like my entire website I'm doing like by hand because I care a lot about making sure it's done right, and I want to make sure that my education, something that I care about, is done good, right? So where I'm going with this, right, is that it's like I've been described as a foodie, right? And I don't think I'm a foodie. I think what I am is I'm somebody who has opinions, and those opinions are something that I have worked through and reinforced and whatever, right? like I have reasoning to my opinions, right? Like for instance, I have a lot of design opinions, right? Like I won't go off on design stuff right now because this isn't a design stream where I'm trying to do like graphic stuff, right? Well, technically I'm doing graphic stuff, but I mean like, you know, like graphic design, right? Like that's not what I'm trying to do right now. But I've encountered a lot, like a non-zero amount of things where I'll like start stating all these opinions and like people are just like, oh my gosh, you seem so educated, you could have a job and blah, blah, blah. And it's like, okay, like cool, like I understand what you're saying and I appreciate it, but like what I'm doing doesn't feel special. It's me feeling like I just simply observe the world, right? You know what I mean? Like, does that make sense? Like this isn't me trying to be condescending, but like I just find a lot of people just are just like kind of idle and just cruising through whatever and just don't care. It's like, dude, like you're telling me you don't really care if you're like, you know, tacos have like beef, chicken, or pork, like you have no preference for it. And then you'll hear somebody be like, oh yeah, well I mean like I guess I prefer beef or whatever, right? It's like, okay, yeah, so you do have a preference. You just like don't support your own preference, right? Like, you don't have, like, a backing behind it, right? And people are like, oh, well, kind of, I guess, right? And it's like, yeah, so, like, you know, like, stick by those opinions. And, like, I'm not saying you have to, like, defend them to the death. I'm just also saying, you know, like, there is a degree of, like, you know, a fun time, right? I don't know, it's thrilling. I don't know. It's all fun. I'm being very, very rambly, but hey, let's see where we go from here. So what I want to do actually is I want to go back and I then want to view the C++ code in a new thing. So first thing we're trying to do is we're trying to find the VK device. So I'm guessing the VK device is going to be towards the top. VK device. Let's just find this. So we're going to do Command F. VK device. So device is in private. Okay. So let's get that and find that. So VK device is in private. Yes, it is. It's right here. So then our next one that we need to find is going to be... We did this, I'm almost certain of. Create logical device. Where is that stored? Create logical device is just below pick physical device. Okay. So let's see, create logical device is going to be just below physical device, so we'll just very quickly yank all that, and we'll make sure it's just below pick physical device. Let's see, pick physical device. Cool, we'll just bounce the end of that, boink. Alright, so now that's there. Let's double check our structure. So let's see, we got the Q indices, we got the VK device, create, Q priority, create info, VK physical device, VK device, create info. Okay, so we're doing it something like this now. Oh, I didn't specify the S type, I don't think. VK device features equals to that. Yeah, VK device create info. Create info. Okay, this isn't called as a class thing, so let's fix that. VK create device info, and then we have just below that we have the whole big line here, which is going to be create info dot s type is going to be equal to VK underscore structure underscore type underscore device underscore create underscore info. Let's see how that do. Whoops. Use of undeclared. Whoops. Let's see what that diagnostic thing is saying. Do you mean VK structure type device? Okay, there's a type 1 device. Let's see. ICE. Okay, VK device create info, yep, create info Q, yep, create info P enabled features. So that seems to be a discrepancy, which is very odd. I don't know what the discrepancy is about. Let's see. So, where are we going from here? So, now that we're here, I need to go... VK enabled features, I'm going to copy this and paste it just to see if something is wrong here, and then we'll go from there if it says it's right. Let's see. Save it. Whoop, that one is right. So I guess I just made a typo or something. Let's see. Two guys are trying to get stuff printed out for what will be my next project, being a replica of Cupcake from the FNAF movie. Hey, that's pretty epic. You do much 3D printing stuff, or is it a new toy, or like how's that sort of line up with you? Is it a whole new is like a whole new world of exploration, and like are you planning to make it like motorized or just kind of like a shell? No pressure, just curious. Get the vibe. Let's see, and then from there we then need to do create info enabled extension count. This is the validation layer stuff, which is there to there. VK create physical device. That's all here. Let's see. Get physical device. Q is this. Bool is device sustainable. Yep is device. Or sorry, not sustainable. Suitable. Q family indices. UN32. Get physical standard vector. VK. Yeah. Then with the loop. Okay, never mind. The bool is a whole new thing. So we should be good. We should be good. I think we're good. Are we good? I hope we're good. Time to find out. Panic and fuck. I don't know. Just try and figure it out. Let's see. I've had it for a while. Started from TAF course. I don't know what TAF is. Is that like an... I think you're Australian, if I'm correct. I could be wrong. I think that seems to be what you've mentioned by, like, you know, refers to mosquitoes as mozzies. From a TAF course, so I'm guessing that's a Australian program. And right now it'll just be the shell, but I need to get the right electronics like servos, Arduino motor shell LEDs, and all that. I don't know if I'd be able to make it remote control. Yeah, I mean, hey, it depends. Yeah, I'm Australian. TAF is a form of education. Fair enough. Cool. And I mean, yeah, I mean, like I do some 3D printing stuff. It's actually funny because I keep telling myself that, like, I'll use my 3D printer for, like, creative stuff, and it's funny because I almost always just end up using it for, like, productive stuff, which is funny. It's just how it goes, right? And then, yeah, I mean, like, I would argue that it's, like, you know, with the whole Cupcake thing, it's, like, it's not that that's, like, a bad project, but I personally see that as, like, a lot more of, like, a shelf hanger, right? And the whole being able to move it around is more of like a party trick, right? So, like, being real, I think that's one of those things where, like, unless you're planning to make, like, a video or like, you know, some sort of other, unless there's something secondary to it that like, why you'd want to do it, I could totally see it just being, like, a paint it and leave it type thing, you know? I mean, of course, you can just do it for the education's sake, because there's nothing wrong with that, but that's just kind of what I'm thinking.
That's my opinion on it. It's my opinion on it because I'm a stupid little person full of opinions.
Okay, so we've done this now. We've verified that the code seems to line up, so we can move on to the next chapter. Huzzah! So, okay, so each one of these needs to be steps. There's 1, 2, 3, 4. So this doesn't seem like it'll be too bad. If we can make good progress, we might actually see a triangle tonight, which will be awesome. Like, it would be a great model, but it would also be useful for, say, someone was filming stuff, got a Cupcake prop lol. Yeah, I definitely get that. I have also fallen in the trap, personally, of, like, planning way too hard for things, and then all that just ends up flopping. You know what I mean? So it's, like, it's one of those things, right, where, like, I do understand that, and if you have friends who do filming, then that is a valid excuse, but, like... Yeah, I don't know. I'm very much a person who I've come around to the idea of, like, retrofitting is better than, like, going way too hard. You know what I mean? So yeah, call me an asshole. Let's see. How big is this one? Is this one a big one or a small one? I think this isn't too big. I think it's kind of smallish. Yeah, that isn't too bad. That's like a quarter of the page, so that's fine. That's fine. That's not so bad. Like, my last print was a small articulated Freddy head with jaw and eyes, which I posted on Discord. On the Discord, actually. Nice. You get some updates for it, or was it mostly gone into the shadow void? Because I know Discord can be painful like that sometimes. All right, let's. I'm gonna start reading through this, and I'll check chat every break. So I'm not ignoring you. I'm just like chipping through it so we can keep the progress rolling. You know. Let's see. So Windows Surface. So the steps are going to be Windows Surface creation, queuing for presentation support, and then creating a presentation. The presentation queue. Since Vulkan is a platform-agnostic API, it does not interface directly with the Windows system on its own. To establish the connection between Vulkan and the Windows system to represent results on screen, we need to use the WSI, Windows System Integration extension. In this chapter, we'll discuss the first one, which is VK Chronos Surface. It exposes a VK Surface Chronos object that represents the abstract type of the surface to represent rendered images to. The surface in our program will be backed by a window that we've already opened with GLFW. The VK Chronos Surface extension is an instance level extension, and we actually already enabled it because it's enabled by the list rendered by GLFW get required instance extensions. The list also includes some other WSI extensions that we'll use in the next couple of chapters. The Windows system needs to be created right after the instance creation because it can actually influence the physical device selection. The reason we postpone this is because the Windows system aren't part of the larger topics of render targets for presentation, for which the explanation would have been cluttered in the basic setup. It should also be noted that the Windows surfaces are entirely optional component in Vulkan. If you need an off-screen rendering, Vulkan allows you to do that without hacks like creating an invisible window necessary for OpenGL. Neat. Windows surface creation. Start by adding a surface class member right below the debug callback, VK Surface Chronos Surface. Although the VK Surface Chronos object and its usage is performed agnostic, this creation isn't because it's dependent on Windows system details. For example, it needs the HWND. HWND, I'm trying to think of what that would stand for. And an H module. My guess is like hardware window is my guess, or like handles Windows or something like that is my guess of what that means. I don't know. That's my assumption. Therefore, there's a platform-specific addition to the extension, which on Windows is called VK_Chronos_Win32_Surface, and is automatically included in this list from GLFW get required instance extensions. I will demonstrate how to perform specific extensions that can be used to create a surface on Windows. We generally won't actually use it in this tutorial. It doesn't make any sense to use a library like GLFW and then proceed to use platform-specific code anyways. GLFW actually has GLFW create Windows Surface that handles this platform differences for us. So it's good to see what it does behind the scenes before we start relying on it. Yeah, that's pretty much why I'm doing Vulkan stuff right now, because I've been playing around with the side thing I guess to like share is I've been playing around with Godot, and I've been kind of playing around with the idea of like an open world game that has like way too many things that are tracked to like make like basically the player drown in stat hell, right? The sort of TLDR with it is that one reason why I'm doing this is because I actually want to do like shaders and stuff in it, right? I might do other stuff too contextually, but that's my kind of idea, right? Let's see. To access native platform functions, you need to update the includes at the top. Pound define use VK platform Win32 Chronos. Pound define GLFW include Vulkan. Pound include GLFW-GLFW3.h. Pound define GLFW expose native Win32. Pound include GLFW/GLFW3 native.h. Because a Windows Surface is a Vulkan object, it comes with a VK Win32 Surface create info Chronos. Holy shit, that's a mouthful. Struct that needs to be filled in. It has two important parameters, HWND and H instance. These are the handles these are the handles to the window in the process. VK Win32 Surface creation info Chronos create info and create info.s type of type VK structure. That is a VK structure type Windows 32 Surface, and then we're creating the info based on the Chronos standard. Create info HWND. GLFW get Win32 window that takes in the argument window. Create info H instance that is equal to get module handle, and the handle is going to be a null pointer. My guess for the reason why it's null is because this is a OpenGL flag or something, and because we're using Vulkan, we don't need it set. That's my guess. The glfw get win32 function is used to get the raw hwnd from the glfw window object. The get module handle calls the return h instance handle of the current process. Okay, I gotta look up what hwnd. HWND meaning... Okay, why am I here? Hold on, did I accidentally close the tab to here? I think I accidentally closed the tab to here. Yeah, I went back, I think. Yeah, I went back. We went back in time. Holy shiz. We should be in presentation, yeah. I meant to do T. I think I hit W by accident just because brain dead. Let's see. HWND Vulkan meaning. Let's see. What is the meaning of Vulkan? No, I don't care about that. HWND meaning. HWND meaning of HWND. Handle to window. Yeah, that's kind of what I thought. Handle to window. Okay, yeah. That tracks. So let's see. Let's see. This I think that's what I said it was, but I just wanted to verify. Let's see. So where are we? So after that service created with the was I there? Yeah, after the service has been created with VK create Win32 surface Chronos, which includes a parameter for the instance creation details, custom allocators, and the variable for the surface handle to be stored in. Technically, this is a WSI extension function, but is also commonly used in the standard Vulkan loader. Is also used that the standard. Oh my god. But it is so commonly used that the standard Vulkan loader includes it. So unlike other extensions, you don't need to explicitly load it. If VK create Win32 surface Chronos, that takes an instance, the address of create info, null pointer, the address of surface is not equal to VK success, throw an error. The process is similar for other platforms like Linux. There's a VK create XCB surface. Chronos takes in an XCB connection and window as creation details with X11. What about Wayland, though? Cry. Let's see. The process is similar. Oh, yeah, sorry, that part. The glfw create window surface function performs exactly this operation with a different implementation for each platform. We'll now integrate it into our program. Add a function create surface that will be called from init Vulkan right after the instance creation and set up debug messenger. So now we're creating the whole create surface, right? Yeah. So we're doing the whole create surface, so I'm guessing this will just be like init the program, add dimension, size, and whatever, right? The glfw, let's do this. The glfw call takes simple parameters instead of strict ones, which makes the implementation of the function very straightforward. Void create surface, if glfw create window surface, instance window, null pointer, address the surface, not equal to Vulkan success, throw an error. The parameters of VK instance glfw. Let me scroll down a little bit more. The parameters are the VK instance, glfw window pointer, custom allocators, and pointer to VK surface Chronos variable. It simply passes through the VK result from the relevant platform call. glfw doesn't offer a special function for destroying a surface, but that can be easily done through the original API. So on cleanup, we're calling VK destroy surface Chronos with reference to the instance, the surface, and the null pointer, and then destroy instance null pointer. Cool. Make sure that the surface is destroyed before the instance. Yeah, my guess is that because the surface will be the window, so if you close the instance, my guess is that the window will stay open and it's just not going to close. So it's basically going to be like a window handler task that's perpetually running in the background until like something explicit is done with it. Let's see. Querying for presentation support. Although the Vulkan implementation may support Windows system integration, that does not mean that every device in the system supports it. Therefore, we need to extend is device suitable to ensure that the device can present images to the surface we created. Since the presentation is a queue-specific feature, the problem is actually about finding a queue family that supports presentation to the surface we created. It is actually possible to, it's actually possible that the queue family supporting drawing commands and the one supporting presentations do not overlap. Therefore, we have to take into account that there could be a distinct presentation queue by modifying queue family indices structure. So structs, queue family, standard optional UN32 underscore type, graphics family, and present family of the same initialization. Bool is complete. Return graphics family dot has value, and present family dot has value. Ooh, that's a lot of reading. Okay. Let's see. Next we'll modify the... next we'll modify... there we go. Next we'll modify the find Q families function to look for a Q family that has the capability of presenting our Windows surface. The function to check for that is vk get physical device surface support Chronos, which takes in the physical device Q family index and surface as parameters. To call it in the same loop as vk Q graphics bit. So vk bool 32. It's very funny that vk seems to have... their own like 32-bit long bool. That's cute. Oh, hey, y'all want to know something fun? I learned a bit ago, which is kind of obvious in post, but I mean also learned this like months ago. But like, hey, it's still a cute thing. So I found out that we'll go look at this white actually. So I actually found out that a Boolean. TLDR, Boolean, a common abbreviated to bool, is, like, it's equal to, like, a true or false value, or, like, like 1 for true, and then 0 for false, right? I learned that, like, let's pretend our system is 16-bit. That basically means that, you have, like, 1, 2, 3, 4, I'm gonna say 8 bits, actually, so 5, 6, 7, 8. So if you have an 8-bit computer, each one of these can be a 0 or a 1, right? And then contextually, those can mean, like, different things, right? These are kind of some sloppy zeros, but you get the idea, right? What I actually found out is that if you create a Boolean that is 1 or 0, due to the way that the system works and is accessed, you basically only change the very last thing. So on your system, all of this is being wasted just for a Boolean call. So that's where I forget exactly what they're called. I know them kind of as like bit flags or something, but basically what you can do is you can basically can use each one of these as an individual flag, which then effectively just, equals like some random number, right? R and D for random. But yeah, so it effectively equals some random number, which is some like random gook, which I found out about, which is like, huh. So, like, I shouldn't feel that bad about using a number in my system, is what you're telling me. So yeah, that was a very cute find out. Let's see. So carrying on from here. I should use Clank format on this. So let's do whoops, not what I meant to do. I meant to do Clang dash format. Ta-da! I did it. I formatted. Let's save it. Okay, let's see. So sorry. So back from that side tangent, I suppose. So, call in the same loop as VQ graphics bit. So, we're checking for present support false. Get physical device surface, and present support. Then simply check out the value of the Boolean and the store representation family Q index. So present support indices equals present family is then equal to I. So I'm guessing this is the loop that's like where is it? I'm guessing that's not that loop. There was one where there was like a plus I. Yeah, right here. I'm guessing it's like right in here that I call it. So is my assumption at least. Let's see. Note that it's very likely that these end up being the same. Q family after all, but throughout the program, we will treat them as if they are separate queues for a uniform approach. It is very likely that these end up being the same Q family after all, although the program will treat them as if they are separate queues for a uniform approach. Okay, so is it talking about like the graphics family and the present family? I'm guessing that's what they mean, are going to be treated as separately. Let's see. Nonetheless, you could add logic complexity to refer to a physical device that supports drawing representation, the same Q for Nevertheless, you could add logic to explicitly prefer a physical device that supports drawing and presentation, the same Q for improved physical performance. I don't know where I got physical from, but improved performance. Let's see, creating the presentation queue. One thing that remains is modifying the logical device creation procedure to create the presentation queue and retrieve the VKQ handle. Add a member variable for the handle VKQ present Q. Next, we'll have multiple VK device Q create info. So VK device, we're querying for the queue, and then we're querying, and then we want to create info. Structs to create a queue from both families. An elegant way to do so is to create a set of all the unique families that are not necessary for the required queues. So you have pound include set. Let's see. So that's probably where the set comes from earlier. That I have a set up here, right? Then I import a set that was like unused. No, I got map, but not set. That's weird. I don't know what that's for. Yeah, I don't really know what to do with that. Yeah, okay, fair enough. So let's see, we're doing Q family indices equal to Q family's physical device. That sounds the same. So then, VK device create info, Q families, indices dot graphics family dot value, indices dot present family dot value. Okay, so I'm guessing when you call something with the squirrely brackets like this, I'm guessing you're passing those in as like arguments. Float Q priority is 1, and then for U42, Q family, create Q info structure, yeah, so all this Q info stuff again, so we're doing the S type, Q family index, Q count, Q priorities, and then pushback, so we're adding it to the end of the list. And then add modify VK device, create info to the pointer vector, create info dot Q create info count is equal to static cast UN32, Q create infos dot size. And create info, create infos, Q create infos dot data. Ooh, new flag dot data. Let's see. If the Q families are the same, then we'll only need to pass its index once. Finally, we call to retrieve the Q handle. VK device Q, device indices, present family value 0, the address of present Q, and that's it. In this case, the Q families are the same. The two handles will most likely have the same value now. In the next chapter, we're going to look at the swap change and how they used to give us the ability to present images to the surface. Okay. Lots of stuff. I noticed I got messaged by close friends, so let me peek close friend peek. Ooh, yes, so good. Let's see. Let's see. Let's see. Okay. Okay, there's my reply to the friendo. The friendo has been replied to. Are we ready to make this file even longer? Let's go! Also, I don't support any of those ads because I don't know what they are, so I can't verify them, so ignore the ads. Let's see, so start adding a surface class member right below the debug callback. Okay, actually, wait, hold on a second. I'm going to go down a little bit more again. I'm going to extend the C++ code. What's this? 9 years ago, Vulkan tutorial. Hey, that's where I am. So, where I'm at right now, so I'm going to try to follow this as close as possible, and when I see discrepancies, I'll just correct the discrepancies, right? So, Windows Surface creation. So, add a surface class member right below the debug callback. So, I'm guessing that's right here is what they're referring to. Because there's kind of a few debug things. Because this is technically the end of the bug, so I guess I'll slap it here. So we'll do VK surface Chronos. And this is going to be of the name surface. I don't know why I have an L there. Surface. VK surface Chronos. Did you mean VK surface? VK surface Chronos. What? What did I spell wrong? CHR. Oh, I spelled CRH. RIP. CHR. Ta-da! I fixed it, Mom. I don't like that down there. I kind of want this to be up here more. Actually, no, wait. Where was it? It was not there. I guess it works there. Okay, sure. We'll go there then. Why not? Let's see. So then after that, we need to add these to the top. So let's add the defines and includes. So, let's see. So we're just gonna go like this, and then we're just gonna say, let's see, for specific platforms, and then we'll do the same thing on the other side. Whoops, whoopsies. Let's fix that. I did not want that. I want you. Yes. Okay, so we're doing pound define. Let's see, vk underscore use underscore platform underscore win32 underscore khr. So that needs to be commented out because we're not using frickin' win32. I'm in caps lock. Oh no. Undo. There we are. So the next one we're doing is, I'll include these ones now. So we'll do pound define glfw underscore include underscore vulkan, and after that we're doing pound include, that's the capitals, I don't want capitals, include, and then we're doing glfw forward slash glfw3.h. I don't know why I did those all in caps. glfw 3.h, pound define glfw underscore expose underscore native underscore win32. I don't care about that because we're on the Linux, baby. I can do some of that good old fashioned, where's Yakuin? There we are. We can do some of that good old neo fetch, baby. Whoa, we're on Linux. Let's go. So then from there, okay, so we got the expose win32, and then last we need pound include. That's not how you spell include. glfw forward slash glfw3 native.h. I forgot a little doobly-doo. I mistyped doobly-doo twice. There we are. Alright, so that's cool. Okay, so after we do that, now we need to jump down to the VK surface create info stuff. So this is going to be, because it's a Windows surface object, it comes with the Win32 surface thing. Struct needs to be filled in with 2 informed parameters. Here are the handles below to do it. So I'm guessing I'm supposed to add this. I don't actually know where I'm supposed to add this. I guess we'll do. I guess we'll do it directly below. No, that doesn't make sense. I don't know where I want to do this. Where do I want to do this? If I get rid of you, does that fix you? Nope. Okay, cool. Okay, I'm just gonna go here then, I guess. So we'll just do vk win 32 surface create info chronos create info. Then we're doing create info dot s type is equal to vk underscore structure underscore type. The type is going to be win32 underscore surface underscore create underscore info underscore khr. After that, we're doing create. Create info dot hwnd. So for our hardware window is going to be equal to glfw get win 32 window. That is of type window. Huzzah. I should probably look for where the create info is. No, maybe. Unknown type. Do you mean create info khr? Create surface vk win. Alright, what's the error going on here? Did you mean vk display surface create info? Oh, you know what? It's probably because the thing at the tops are commented out, so I should probably just uncomment those for now, and then just kind of oopsie daisy move on. Windows BS, and then we'll also do Windows BS. Because I know these aren't specifically like a Windows issue or whatever, but I like blaming Windows anyways, because it's fun. Let's see, includes file, windows.h, file not found. Excuse you? What did I type wrong? Define, include. So define, include. I don't see any terminators that I'm supposed to add for this. That has square brackets, and this has square brackets. The others don't. An included file 1h.32.found. Oh, because it is probably because it's Windows BS. So that's probably the issue. So we'll do this. We'll do that. I guess I'll just skip this because I can't really do much with it, right? Because I'm not on Windows. And they said that they wouldn't implement it either. So Windows BS. Yeah, I don't really know what to do about this because like it's Windows only, right? So, oh, here's what I'll do instead. I'll skim through here and I'll kind of do all the corrections that I'm supposed to, right? And then we'll kind of go from there because I don't really want to waste time on this. So, I noticed they're moving stuff around here. So we got IO stream. So IO, whoops. Let's see. So we got, oh my gosh, undo. We got IO stream here. Let's see, we got standard exception, which is now going to be up here. Vector, this whole list has been reversed, hasn't it? So we got C string, which now is going to be up here. Standard lib, optional. Then we got set, so pound include set. Yep. These kind of make sense enough, so we can carry on with you. We need the vulkan.h, surprise. So let's see, we've got the width and the height here. So width and the height works. Map will be fixed. Sorry, set will be fixed. Not sure about map. So we have to define. We got the validation layers called, don't we? Yeah, the validation layers call is here if in debug. So this got swapped around for some reason. I guess I'll move you. Let's see. Let's fix these ones. We'll replace it with a 2. There we are. So we got all that. Let's do a quick format. Clang dash format. Whoops, that's the wrong one. Whoops. Let's undo that. We'll run the same command but without the 5. There we go. Huzzah! So now that we got that done, so now we got the Cronus validation set. Validation layer is equal to, excuse me, why did that seem to error? Why does this seem very wrong? Oh, because that's how Clang formatted it, that's why. It's formatted very stupid, so that threw me off. Let's see, we got the if and debug thing, we got the VK result, create debug utils, that seems to be about the same. Let's see, destroy messenger VK instance. I don't even know if I want to do that though, because they said it was optional. So I don't really want to do that because that seems very Windows specific. So I guess I'll have to just move forward and just smile and nod and whatever. I guess. I don't know. That's what I'm kind of leaning towards because I don't really know what else I would be doing because I'm a freaking cracker and barrel. You've been lurking, but I'm gonna head out now. Good luck on the Dorito, and I hope to talk soon. Yeah, totally. I'll probably hit you up. I'm planning to make this a shorter stream, honestly. So I'll probably hit you up in about an hour on the Friday thing and just kind of poke you about when like time would be good and whatever, right? So if not, then I'll probably follow up tomorrow on that if I remember, because I have a small, tiny brain that's stupid. So yeah, there's that. So I mean, hey, no pressure. But yeah, so I'll catch you then. If I don't message you tomorrow, then hopefully remember to message me, and we'll figure it out. But yeah, have fun, GL, and yeah, already sounds good. If not, I will message you, lol. Yeah, I'm like debating. You know what? Screw it. We're gonna go this far. Set a reminder tomorrow morning at 9 o'clock to message Holy about stream.
What do you want to be reminded about?
Thanks, Siri.
Okay. You're welcome.
Okay. Let's see what Siri actually took down out of that, because that very much did not seem like a proper thing, shall we? Let's very quickly skim what they added. So this is probably gonna be added to my general list, right? It says message Harley about stream. You hear that, Harley? You hear that? We're talking about Super Mario 64. Damn, Harley! I didn't know you lied to me about your name. So like, how's the motorcycle company going? I don't know. What? I don't know. Okay, for real, like micro side rant, like before you wiggle off. I have no idea what it is. My Siri has been insane. So here's actually a fun fact. So there are two places that are considered to have like quote unquote pure English like accents, right? One of them is like in like the west coast of Canada, and the other is I think like Virginia, and I live in one of those. So I have what is debatably like the purest like English like accent. Like I have the least accent for somebody who speaks English, right? And I don't know why. I have the consistently hardest time with Siri. And I'm so upset about it because it's like I literally have like a language privilege that like by birth is like, hey, guess what? I have like what people largely consider to be like the correct way to say words in English, right? Yet I just get fucked over by like Siri. Commonly. So it's like, what the hell, man? It's so stupid. It's so stupid. Anyways, I think I'll end it there so I don't keep you too long. So Siri's just not that great. So that checks out. Yeah, no, Siri is honestly fucking shocking. TLDR, I watched a video on it, and it seems like Apple over the years has had no idea how to deal with Siri, and there's like two individual departments working on it at the same time, but none of them can ever push features, and it's a whole mess. Anyways, yeah, I don't want to keep you on too long. So, hey, have fun with whatever you got going on. Good luck with whatever you got going on, and I'll catch you later, Holy. Have fun. Goodbye. See you later. Yes, bye. Good luck again. Thank you. I will be suffering with the Dorito triangle. I don't know how long this is going to be, so we'll have to see. Anyways, I will stop referring to you directly, Holy, so we can see. Oh, this is a big one. Oh, this is a big one. Oh, that's a big one. Oh, that's a big one. Okay, I want to see very quickly for planning if the next one can render the Dorito. Oh no, we're not even there. We're on the swap. Oh no, these are three different things. Okay, we'll try get to I think image views. I think image views will be the one that's good to end on. Because if we can do, yeah, image views is very small. So if we can do the image views, I think that's a good place to stop. I think that's a good place to stop for the night, because I have other things I want to work on as well, and stuff that I need to do because of like work and whatever, right? So I think that's a good line.
Well, come on then, you whiny baby boy. Oh, I know, life is so tough, isn't it? Oh, you just get to chill out, you get to eat all the food you want, you get to go for something that goes WALK. Because I know I'm so mean, aren't I? I'm so mean, aren't I? Oh, yes. You ate half a freaking pizza today. You have nothing to be whiny about. You know that? You know that? You know that? I ordered a medium pizza and you ate all the crust. You ate all the crust, you freaking goober.
My boy, my lad, he's a goober and he's my world. Okay, so let's see. So, I don't think that, how do I put this? I don't think that there's much for me to do outside of like with the previous one, because they said it was going to be used mostly as like an auxiliary thing. So I think what I'll do is I'll try to follow this tutorial until the end, and then once I reach the end, like the drawing stage, then I'll reset, and I'll, whoops, did not mean to do that. Then I'll basically reset my file if it doesn't compile, because like I don't know what the hell is up with some of these. Like standard optional does not exist. Like what the hell is up with that? Let's see. No template named optional in namespace standard. Yeah, you can see I already googled this for like 5 minutes. I didn't get very far. We'll take another quick peek and see. I don't care about this because this isn't a thing called Pistache, which is some library, which is not something I care about. So let's just fix that very quickly. So no template name optional. Whoops, I did not mean to grab the Xcode thing. Let's take a little peek at this, shall we? Let's see, include optional. Let's see, this is very odd. I don't have Xcode 12 installed. The end, your compiler errors for me. Is it a CMake issue? Is that the issue? So I go here, dash. Let's try dash C so dot CPP, because that's the line it's showing. And then try main again. No optional included. Let's see. Inkscape build failure. That's awesome. Let's see. I see this on macOS Mojave. Cool, not sure optional, but only valid on C17, so it's probably not used enough in the compiler for the older systems. That's right, looks like it's popular now, requiring dependencies to build a C17. Am I building as like C11? Is that the issue? No, I'm building a C17. Standard is equal to C++. Let's see. There doesn't seem to be much I can do. I have it set to that. Let's try add Linux to the end of this and see what we get. And if nothing happens, then we'll see. Linux. No template named optional in space standard. Let's see. Here's my package.json file. That's an issue with React Native. Oh, this is because it's something else entirely. C++ namespace standard does not contain optional. GLFW. Okay, so this is from the Vulkan tutorial. Okay, somebody else had the issue. Or compiling with C17 to support this type was added in C17. Many compilers still default to C14. Standard optional requires that. Live on Godbolt, you can use / standard C17 flag on MSVC, and that on Clang, GCC-Clang. Okay, so I'm doing dash standard is equal to C17. Maybe it's just all the extra stuff is like confusing it. Maybe that's the issue. Let's see. Maybe that's the issue. If it doesn't work, then I'll just roll with it and hope that the compile like fixes it. So yeah, that doesn't seem to be doing anything. So I guess we'll just cry and deal with it. Let's see. Checking for swap chain support. Okay, yeah. So we're reading through this. So let's see. Vulkan doesn't have the concept of a default frame buffer, hence why it requires an infrastructure that will own the buffers we will render to before we initialize them on screen. This infrastructure is known as a swap chain. It must be created explicitly in Vulkan. The swap chain is essentially a queue of images that are waiting to be presented to the screen. Our application will acquire such an image to draw to it and then return the queue. However, how exactly the queue works and the conditions for presenting the image on the queue are dependent on how the swap chain is set up. Yeah, there it is. But the general purpose of the swap chain is to synchronize the presentation of images with a refresh rate of the screen. Yeah. It sounds like sort of like pseudo vsync, basically. Checking for swap chain support. Not all graphics cards are capable of presenting images directly to a screen for various reasons. For example, because they're designed for servers and don't have any display outputs. Secondly, since image presentation is heavily tied to a Windows system and the surfaces associated with the Windows, it is not actually part of the Vulkan core. You have to enable the VK Chronos swap chain device extension after querying for its support. For that purpose, we'll first extend the is device suitable function to check for if this extension is supported. We've previously seen how to list extensions that are supported by a VK physical device, so doing so should be fairly straightforward. Note that the Vulkan header file provides a nice macro VK Chronos swap chain extension name that is defined as VK Chronos swap chain. The advantage of using this macro is that the compiler will catch misspellings. First, declare a list of required device extensions, similar to the list of validation layers to enable. Const standard vector, const character pointer to device extensions. Const standard a vector of type const character named device extensions that is equal to VK Chronos swap chain extension name. Okay. I can fuck with it so far. Next. Next, create a new function, check device extension support that's called from is device suitable as an additional check. Bool is device suitable, VK physical device, Q family indices equals find Q families argument device, Bool extension supported, check device extension support device, return indices dot is complete and extension supported, Bool check device extension support, VK physical device, return true. Let's see, modifying the body of the function to enumerate the extensions and check if all required extensions are amongst them. Let's see, Bool check device extension support, VK physical device, UN32 extension count, VK enumerate device extension properties, device null pointer, the address of extension count, and a null pointer. Standard vector of type VK extension properties, available extensions, takes in the arguments extensions count. VK enumerate device extensions properties, device null pointer and extension count, available extensions dot data. Standard set standard string. Standard set of type standard string required extension takes in the arguments device extensions dot begin, device extensions dot end. Okay, so it's basically just creating a string, a set. A set being like an array, but each thing is unique, and it's a string. And it's basically just creating the string to be as long as the device extensions are explicit for or whatever. For const auto with the address of extension. For const auto with the address of extension, available extensions. So basically, for the length of available extensions, required extensions dot arrays, extensions dot extension name. So basically, if the what I'm interpreting this as is basically, so we're basically creating an array or like a set of device extensions that are, and then if the extensions are all supported, then return empty because that means it's all happy, and if not, then other issues. Let's see, I've chosen to use a set of strings here to represent the unconfirmed requirement extensions. That way we can easily tick them off while enumerating the sequence of available extensions. Of course, you can also use a nested loop like in check validation layer support. The performance difference is irrelevant. Now run the code and verify that your graphics card is indeed capable of creating a swap chain. It should be noted that the availability of a presentation queue, as we checked in the previous chapter, implies that the swap chain extension must be supported. However, it's still good to be explicit about these things, and extensions does have to be explicitly enabled. Okay, so I think what I'm going to do now then, just because of that, I think what I'm going to do at the end is I'm just going to clear basically all of this. I'm going to set my entry file to be like main2. And then I'll run that to make sure that it runs, because if I actually jump down, where's the file? Where's the file? Where's it at? It's almost halfway, I think. So we're down here. Yeah, almost halfway. So if we open the code, a new one, I want to see if I try run the code. Okay, I'm just going to Command F for swap and see if swap comes up. Yeah, okay, so this is the file, so we'll copy this, then we'll jump over into main2, and then we're going to do paste, and then we're going to paste that. Okay, so then now what I want to do is I want to go back to the frickin' file browser, and then I want to see in the make file, instead of doing the entry point as main, we'll do main2. And then we'll try make. Missing separator, stop. Make file on 15. Okay, so make file on line 15. So that's fine, I don't care. So we're going to go to line 15. Okay, that seems to be just unhappy, so we'll just do that and just kind of reset that. So let's try make. Let's see, make no rule to make targets needed by vulkan test. What? No rule to make targets mains to needed by what? Okay, what if I just do like clang plus tilde forward slash main main2 dot cp push error no such directory. What? ls dash a what? Oh, it's main underscore 2. That's probably the error. I don't know why I did that with an underscore 2. That's very odd for me, but sure, I guess. Let's see. So main2, save it, quit it. Let's redo a make. Okay, so now if I do ls-a, I should have a Vulkan test. I don't know where that other stuff is coming from. Oh, because I'm trying to call an application / Vulkan test. Yeah, that makes sense. Searching for ICD drivers named Intel Hask, Radeon, Nuvo, Intel Hask, libvulkan Intel, GLX NVIDIA, Vulkan Radeon, loader instance extension, PP extension enabled file name is null, but the enable extension count is greater than 0, failed to create instance. Ooh, spicy. So is that because, I just want to very quickly check, is that because if we go into here, does this have the Windows thing? Like if I do like Win32, it does not. Okay, so then what? Okay, so I don't actually understand that error then. So if we clear, let me try rerun the Vulkan test. So it's searching for all of these. Instance PP extension names is null, but enable extensions count is greater than 0. Okay, so let's just see where that is. So if we do Command F and then we do is greater than 0. Is greater than, yeah. Okay, it is greater than. Okay, and there's nothing here, so that's odd. Maybe that's like one of those like support things. So maybe if I go back to here and I go to here and I go to where is it? I want to go to the entry point. And then I want to not init Vulkan. I mean, I do want to, but I that's not what I'm looking for. I'm looking for I want to disable the debug messenger and see if that maybe fixes it. So let's do a quick save and quit. Then we'll run Vulkan test again. Same issue. Okay, that's odd. I don't know what to do about that, so I guess I'll just smile complacently and just march on forward with this. I think I'll read the next two. Okay, so just because of that, because it told me to run it, I think I'll just read this next bit. And then after I read these next bits, I think I'll probably just, like, try and play with this offline a little bit and, like, see what I can do, because I don't want to, like... I don't want to turn this into another debugging stream. Like, yesterday we were kind of hanging out, so it was cool. Or not yesterday, the day before, it was kind of hanging out and cool, right? But I don't want to keep that up, because I don't want to just make every... you know, stream like a debug stream and like figure stuff out right. Plus other stuff I want to get to. So yeah, we'll keep this one cute, condensed, concise, whatever words. Yeah, yay. Let's see. So we did that. So let's see. Create a new function. Check device extension support that's called from is device suitable to make an additional check. Is device suitable? Yeah, I think I read all that. Modify the function to enumerate. Yeah, okay. So we're talking about why they chose a set. Which the set was down. No, I think we might have went past it. This looks vaguely like it, but I don't know if that was it. Yeah, here it is. Okay, so here we are. I've chosen to use a set of strings here to represent the unconformed requirements of the extensions. That way we can easily take them off while enumerating the sequence of available extensions. Of course, you can also use a nested loop like in check validation layer support. The performance difference is irrelevant. Now, in the code to verify your graphics card is indeed capable of creating a swap chain. It should be noted that the availability of the presentation queue, as we checked in the previous chapter, implies that the swap chain extension must be supported. However, it's still good to be explicit about things, and the extension does have to be explicitly enabled. Rar, hello, Adam. How does the Atom do? We're onto the swap chain stuff of the GPU Vulkan stuff, so that's fun. Playing around with all that other wonderful kippity carpet, trying to deal and suffer with all this crap, so that's fun. Let's see. Enabling device extensions using a swap chain requires enabling the VK Chrono swap chain extension first. Enabling the extension just requires a small change to the local device creation structure. So create info enabled extension count is equal to static cast UN32 device extension size. Create info PP enabled extension name is equal to device extensions dot data. Make sure to replace the existing line. Create info dot enable extensions count equals 0 when you do so. Okay, so that might have been an error for something. No, because I'm pretty sure I pasted the file into, yeah, because I was trying to compile to main 2, so that's an issue. Let's see. Querying the details of the swap chain support, just checking if the swap chain is available is not sufficient because it may not actually be compatible with our Windows Surface. Creating a swap chain also involves a lot more settings than instanced a device and creation, so we need to query for some details before we proceed. There are basically three kinds of... Let me adjust my mouse a little bit. There are basically three kinds of properties we need to check. Basic surface capabilities, min-max number of images in the swap chain, min-max width and height of images, surface formats, pixel format, color space, available presentation modules. Similar to find Q families, we'll use a struct to pass the details around once they've been queried. The three aforementioned types of properties come in the form of the following structs and list of structs. Struct swap chain support details, VK surface compatibilities, Chronos capabilities, standard vector of type VK surface format Chronos formats, standard vector VK preset mode Chronos, vector of type VK preset mode Chronos, present modes. Let's see. Now we'll create a function. Now we'll create a function query swap chain support that will populate the structure. Let's see. Swap chain support details. Query swap chain support. VK physical device. Swap chain support details of. Create a variable of the class swap chain support details. Name details. Return the details. Variable. This section covers how to query the structs that include the information, meaning that these structs and exactly which data they contain is discussed in the next section. Let's start with the basic surface capabilities. These properties are simple to query and are returned in a single VK surface capabilities chrono structure. Let's see. VK get physical device surface capabilities chronos. That takes in the arguments of device, surface, and details compatibilities. This function takes the simplified VK physical device and VK surface Chronos Windows surface into account when determining the supported capabilities. All the supported querying functions have these two as first parameters because they're a core component of the swap chain. That tracks. Let's see. The next step is about querying the supported surface formats because there's a list of structs. It follows the familiar ritual of two function calls. UN32 format count, VK get physical device surface, formats Chronos, that takes in the arguments of device, surface, the address of format count, and a null pointer. If format count is not equal to 0, details.formats.resize format count, VK get physical device surfaces from formats Chronos, that takes in the arguments of device, surface, format, the address of format count, details, formats, and data. Yay. Make sure the vector is resized to hold all the available formats, and finally querying the support presentation modes work exactly the same way with VK get physical device surface present modes Chronos. UINT32 preset mode count VK get physical device surface presentation mode Chronos device surface presentation mode count and null pointers arguments. If present mode count is not equal to 0. Details, present modes, resize, present mode count, VK get physical device surface, present modules modes Chronos, they're taking the arguments of device surface, present mode count, details, present modes, and data. All of the details are in the struct now, so let's extend is device suitable once more to utilize this function to verify the swap chain support is adequate. Swap chain support is sufficient for this tutorial if there is at least one supported image format and one supported image presentation mode given to the window surface we have. So let's see, bool swap chain adequate equals to false. If extension supported swap chain support details of type, if extension is supported, create a class of swap chain support details, name swap chain support, that is equal to query swap chain support, that takes in the arguments of device. Then a new variable swap chain adequate, the variable swap chain adequate is going to be equal to the opposite of swap chain support.formats.empty and the opposite of swap chain support.presentmodes.empty. Whoops. It is important that we try to query the swap chain support after verifying the extension is available. The last line of the function changes to return indices.is complete and extension supported and swap chain adequate. Whoops, I clicked on the wrong thing. Let's see, choosing the right settings for the swap chain. If the swap chain adequate conditions were met, then the support is definitely sufficient. But there are but there may be still many different modes of varying optimality. We now have to write code for a couple of functions to find the right settings for the best possible swap chain. There are 3 types of settings to determine: surface format, color depth, presentation mode, conditions for swapping images to the screen, swap extent, resolution of images in swap chain. For each one of these settings, we'll have an ideal value in mind that will go with if it's available, and otherwise we'll create some logic to find the next best thing. Surface format. The function for this setting starts out like this. We'll later pass the formats member to the swap chain support details struct as an argument. VK surface format Chronos, choose swap surface format, const standard vector of type surface format Chronos. That points to the address of available formats. Neat. Each VK surface format Chronos entry contains a format and a color space member. The format member specifies the color channels and types. For example, VK format _ B8, G8, R8, A8. I'm guessing that's like blues 8 bits, greens 8 bits, reds 8 bits, and alpha is 8 bits. And then it's using the color space of sRGB. Means that we store the BGR and the alpha channels in that order. With an 8-bit unsigned integer for a total of 32 bits per pixel. Yeah, so basically called it. So I think I said 8 bits. Maybe I said bytes. I don't know. I feel like I said 8-bit wrong. I'm being silly. The color space member indicates that the sRGB color space is supported or not using the VK color space sRGB nonlinear Chronos flag. Note that this flag is used to be called VK color space sRGB nonlinear Chronos. Okay, so there's the underscore that's been changed in old versions of the specification. For the color space, we'll use sRGB if it's available because it results in more accurate perceived colors. It also is pretty much the standard for color space images, like the textures we'll use later on. Because of that, we should also use an sRGB color format. One of the most common ones is VK _ format _ B8, G8, R8, A8, sRGB. Yay. Let's go through the list and see if there's a preferred combination that's available. If const auto, that points to the address of available formats. If available format dot format is equal to VK _ format _ B8, G8, R8, A8 _ sRGB, and available for format dot color space is equal to VK color space sRGB nonlinear Chronos, then return available format. If that fails, then we can start ranking the individual formats below on how good they are, but in most cases it's okay just to settle with the first format that's specified. So a new class, a function. No, is it a function or is it a class? I think it's a function. Function VK surface. Function that will return type VK surface format Chronos, named choose swap surface format. Will take in the arguments of const standard vector of type VK surface format Chronos. That points to the address of available formats. For const auto, the address of available formats. If available format dot format is equal to VK format B8, G8, R8, A8 _ sRGB, and available format dot color space is equal to VK format space sRGB nonlinear Chronos, return available format. Else return available formats of the first entry, like as an array, like accessing the first item with the index of 0. I guess that's the way to put it. Presentation mode. Presentation mode is arguably the most important setting for the swap chain because it represents the actual conditions for showing the images between the screen. There are 4 possible methods available in Vulkan. VK present mode immediate. Images submitted to your applications are transferred to the screen right away, which may result in tearing. VK preset mode FIFO. I'm going to pronounce that FIFO _ Chronos. The swap chain is a queue where the display takes an image from the front of the queue when the display is refreshed, and the program inserts rendered images at the back of the queue. If the queue is full, then the program has to wait. This is most similar to vertical sync found in modern games. The moment that the display is refreshed is known as a vertical blank. VK preset mode FIFO relax Chronos. This mode only differs from the previous one if the application is late and the queue was empty at the last vertical blank. Instead of waiting for the next vertical blank, the image is transferred right away, and when it finally arrives. This may result in visible tearing. VK preset mode, mailbox Chronos is another variation of the second mode. Instead of blocking the application when the queue is full, the images that are already queued are simply replaced with a newer one. This mode can be used to render frames as fast as possible while still avoiding tearing, resulting in fewer latency issues than the standard vertical sync. This is commonly known as triple buffering, although the existence of 3 buffers alone does not necessarily mean that the frame rate is unlocked. Only the VK preset mode, FIFO Chronos mode is guaranteed to be available, so we're going to have to write a function that looks for the best available mode. VK preset mode Chronos, choose swap present mode, we're creating a const of the standard vector VK present mode Chronos that points to the address of available present nodes, and then we're returning the VK preset mode FIFO Chronos. Let's see. I personally think that VK preset mode mailbox Chronos is a very nice trade-off of energy usage. If energy usage is not a concern, it allows us to avoid tearing while still maintaining fairly low latency by rendering new images that are as up to date as possible until right until the vertical blank. On mobile devices where energy use is more important, you'll probably want to use VK preset mode FIFO Chronos instead. Let's look through the list to see if VK present mode mailbox Chronos is available. So let's see. So VK present mode Chronos, choose swap preset, we're creating a const of a standard vector of the type VK present mode Chronos that points to the address of available presets. For each available preset mode, we're basically saying if the available preset mode is equal to the mailbox variant, then we'll return the available preset mode, and then else we'll return the standard FIFO Chronos, the default, the one that's guaranteed to be supported. Swap extent, that leaves only one major property for those for which we'll add one last function. Returns type VK extent 2D, choose swap extent, const VK surface capabilities Chronos, that points to the address of capabilities. The swap extent is the resolution to swap chain images and it's almost always exactly equal to the resolution of the window that we were drawing pixels in. More on that in a moment. The range of possible resolutions is defined to the VK surface capability structure. Vulkan tells us to match the resolution of the window by setting the width and height and the current extent member. However, some of the window managers do allow us to differ here, and this is indicated by setting the width and the height in the current extent to a special value. The maximum value of a uint32 type. In this case, we'll pick a resolution that best matches our window within min image extent and max image extent bounds, but we must specify the resolution in the correct unit. GLFW uses 2 units when measuring sizes, pixels, and screen coordinates. For example, the resolution width height that we specified earlier when creating the window is measured in screen coordinates, but Vulkan works in pixels, so the swap chain extent must be specified in pixels as well. Unfortunately, if you are using a high DPI display like Apple's Retina displays, the screen coordinates don't respond to pixels. Instead, due to higher pixel density, the resolution of the window in pixels will be larger than the resolution of the screen coordinates. So if Vulkan doesn't fix the swap extent for us, then we can't use the original width height. Instead, we must use GLFW get frame buffer size to query the resolution of the window in pixels before matching it against the minimum and maximum image extent. Let me take a little shippy of water. A big little shippy. So shippy. I don't know why my eyes are like melting on this. It's just like, oh, buddy boy. Very fun. Let's see. So include C standard int necessary for uint32. Include limits necessary for standard numeric limits. Include algorithm necessary for standard clamp. VK extend, choose swap extend. Const standard, VK surface capabilities Chronos and that points to the address of capabilities. If capabilities dot extent dot width is not equal to standard numeric limits of type UN32 type max. Return capabilities current extent. Else, whoops, I clicked into the wrong thing because that keeps popping up. Else, go away, go away, go away, go away, go. What are you doing there? You're not supposed to be here. Okay, I guess I'm restarting Zen real quickly. Hello, goodbye. I want to go here. Oh yeah, we were right here on the swap chain. And then we were down at the one where they added the first comments. Oh, I made it further than I thought. I think we're about halfway through this. So, hey, let's go. Let's see. So, they were saying, hey, return capabilities at current extent, else int window width and height, GLW get frame buffer size, window the address of width and the address of height, VK extent 2D, actual event is equal to static cast UN32 of type width, and then standard cast UN32 underscore type height. Let's see. Actual extent dot width is equal to standard clamp. Actual extent dot width, comma capabilities min image extent dot width. Capabilities dot max image extent dot width. Okay, so then it's the same thing for height. Return actual extent. The clap function is used here to bound the values of width and height between the allowed minimum and maximum extents that are supported by the implementation. Creating the swap chain. Now that we have all of these helper functions assisting us with the choices we now have, we have to make at runtime, we finally have all the information that is needed to create a working swap chain. Create a swap chain function that starts with the results of these calls and make sure to call it from init vulkan after logical device creation. So init void vulkan, create instance, set up message debugger, create surface, pick physical device, create logical device, and then create swap chain. And then void create swap chain support detail. A variable of swap chain support details named swap chain support is equal to query swap chain support that takes in the argument physical device. A variable named a variable of type VK surface format chronos named surface format is equal to choose swap surface format that takes in the argument swap chain supports formats. A variable of the type VK present mode chronos named present mode is equal to choose swap present mode that takes in the argument swap chain support dot present modes. And then the last variable VK extent 2D named extent is equal to choose swap chain extent that takes in the arguments of swap chain support dot capabilities. Let's see. Aside from these properties, we also have to decide how many images we would like to have in the swap chain. The implementation specifies the minimum number that it requires to function. uint32 type image count is equal to swap chain support dot capabilities dot min image count. However, simply sticking to this minimum means that we may sometimes have to wait on the driver to complete internal operations before we can acquire another image to render to. Therefore, it is recommended to request at least one more image than the minimum. UN32 type image count is equal to swap chain support dot capabilities dot minimum image count plus 1. We should also make sure not to exceed the maximum number of images while doing this, where 0 is a special value. That means that there's no maximum. If swap chain support capabilities dot capabilities dot max image count is greater than 0 and image count is less than swap chain support dot capabilities dot max image count, image is equal to swap chain support capabilities max image count. As is traditional with Vulkan objects, creating a swap chain object requires filling in a large structure. It starts out very familiarly. VK swap chain create info chronos create info dot s type, which is equal to VK structure type swap chain create info chronos create info surface. After specifying which surface the swap chain should be tied to, the details of the swap chain images are specified. Create info min image count. I'm gonna skip all the where the axes are. So actually, no, I'm gonna read them all. Fuck it. Never mind. Let's see. Create info min image count is equal to image count. Create info image format is equal to image format dot format. Create info image color space is equal to image format dot color space. Create info image extent is equal to extent. Create info image array layers is equal to 1. Create info image usage VK image usage color attachment bit. Whoops, go away. The image array layer specifies the amount of layers each image consists of. This is always 1 unless you're developing a stereoscopic 3D application. The image array layer specifies the amount of layers each image consists of. This is always 1 unless you're developing a stereoscopic 3D application. Okay. So basically, the image array layers is, so it's always 1 unless, like, you're doing stereoscopic 3D. I mean, there's other exceptions that I can think of, like, for instance, if you're doing, like, multi-billboards, right? I could see that being a thing where, like, you're rendering, like, different, like, cameras at once, right? To keep it, like, contextually similar, right? I could see that. Yeah. Let's see. The image usage bit field specifies what kind of operations we'll use the images in the swap chain format for. This is, in this tutorial we're going to render directly to them, which means that they're used as a color attachment. It's also possible that you'll render images into a separate image first to perform operations like post-processing. In that case, you may use a value like VK image usage transfer DST bit instead, and use a memory operation to transfer the rendered swap image to the swap chain. Let's see, Q family indices. Indices is equal to Q family indices. That takes the argument of the physical device. UN32 type Q families indices, which is an array, is going to be equal to indices.graphicsFamily.value and indices present family.value. If indices.graphicsFamily is not equal to indices present family, create info image sharing mode equals VK sharing mode concurrent. VK info Q family index count is equal to 2. Create info PQ family indices Q family indices. Else create info image sharing mode VK sharing mode exclusive. VK Q family index count is equal to 0. Create info PQ family indices, which is a null pointer. Next, we need to specify how to handle swap chain images that will be used across multiple Q families. That will be the case in our application. If the graphics queue family is different from the presentation queue, we'll be drawing the images in the swap chain from the graphics queue and submitting them on the presentation queue. There are 2 ways to handle images that are accessed from multiple queues. The first is VK sharing mode exclusive. An image is owned by one queue family at a time, and its ownership must be explicitly transferred before using it in another queue family. This this often offers the best performance. The alternative is VK sharing mode concurrent. Images can be used across multiple queue families without explicit ownership transfers. If the queue families differ, then we'll be using the concurrent mode in this tutorial to avoid having to do the ownership chapters, because these involve some concepts that are better explained at a later time. Concurrent mode requires you to specify in advance between which queue families the ownerships will be shared in using the queue family index count and P queue family indices parameters. If the graphics queue family, presentation queue family are the same, which will be the case on most hardware, then we should stick to exclusive mode, because the concurrent mode requires you to specify at least 2 distinct queue families. Let's see. Create info pre-transform is equal to swap chain capabilities concurrent transform. We can specify that a certain transform should be applied to the images in the swap chain if it is supported. So we're transforming capabilities. Like a 90-degree clockwise rotation or horizontal flip. To specify that you do not want any transforms, simply specify the current transform. Create info composite alpha is equal to VK composite opaque bit chronos. Let's see, the composite alpha field specifies the alpha channel that should be used for blending with the other windows in the Windows system. You'll almost always want to simply ignore the alpha channel, hence why VK composite alpha opaque bit chronos. Create info presentation mode equals presentation mode. Create info clipped equals VK true. The presentation mode member speaks for itself, and the clipped member is set to the VK true. Then that means that we don't care about the color mix of pixels that are obscured. For example, because another window is in front of them, unless you really need to be able to read those pixels back to get predictable results, then you'll get the best performance by enabling clipping. Create info old swap chain is equal to null handle. This leaves us one last field, old swap chain. With Vulkan, it's possible that your swap chain becomes invalid or unoptimized while your application is running. For example, because the window was resized, in that case the swap chain actually needs to be recreated from scratch, and reference the old one must be, sorry, and then the reference to the old one must be specified in the field. This is a complex topic that we'll learn more about in a future chapter. For now, we'll assume that we only ever have, we'll only ever create one swap chain. Yeah, so this would be effectively how you do, like, window resizing. Like, if you go and put, like your graphics settings into, like, game or whatever, and then it's, like, you see, like the full screen and, like, the drop-down HUD, that's, like, the resolutions. That makes sense that, like, this is what that is. Let's see, now a class member is stored to the VK swap chain Chronos object. VK swap chain Chronos, name swap chain. Creating a swap chain is now as simple as calling VK. Creating a swap chain is now as simple as calling VK create swap chain Chronos. If VK swap chain Chronos device in the address of create info null pointer, and the address of swap chain is not equal to VK success, then throw an error that says failed to create swap chain. The parameters are whoa. What did I click on? Okay, I see. So these are clickable. I think no. Okay, I went way off. Let's see where we're at again. So, I apologize. Let's see. We were not there yet. We were up here more. I think we were... Yeah, we failed to create the swap chain, so that's about where we were. So then, the parameters are the parameters are the logical device swap chain creation info, optional custom allocators and pointers to the variables to store in the handle. No surprises there. It should be cleaned up using VK destroy swap chain Chronos before the device. VK clean up destroy swap chain Chronos device swap chain null pointer. Now run the application, ensure that the swap chain is created successfully. If at this point you get access violation error and create swap chain Chronos, you'll see a message like this: failed to find VK instance proc address and layer in the Steam overlay vulkan layer.dll. See the FAQ entry about Steam overlay error. Does that mean like Valve Steam, like like the gaming company? That is very odd. Okay, I will jump back then, and I will keep reading and see what it says. Try moving the create info. Try removing the create info dot image extend equals extent line with validation layers and labeled. You'll see that one of the validation layers immediately catches the mistake and his helpful message is printed. Validation layer VK swap chain Chronos called with pinfo create image which will not be equal to the current extend returned by VK get physics Chronos. Okay, so I want to see if I disable that. So it was saying disable the create info. I just realized there was a typo there. So let's see. So we're doing create info dot image extent. Because I misspelled it again. Goddamn. Create info dot image. I mistyped that image. Okay, so this isn't running then. Okay, so I guess I'll just paste this code in here and see if it runs. Retrieving the swap chain images. Swap chain images have been created now, so all that remains is retrieving the handles of the VK images in it. We'll reference these during rendering operations in later chapters, adding a class member to store the handles VK standard vector of type VK image. Named swap chain images. The images were created by implementation for the swap chain. They will be automatically cleaned up once the swap chain has been destroyed. Therefore, we do not need to add any cleanup code. I am adding code to retrieve the handles to the end of the create swap chain function right after the VK create swap chain Chronos call. Retrieving them is very similar to any other times where we retrieved an array of objects from Vulkan. Remember that we only specified a minimum number of images in the swap chain, so the implementation is allowed to create a swap chain with more. That's why we will first create the file number of images with the VK get swap chain images Chronos, then resize the container, and finally call it again to retrieve the handles. Okay, so VK swap chain images Chronos, device swap chain, the address of image count, and a null pointer. Swap chain images dot resize image count, VK swap chain images Chronos, device swap chain, the address of image count, swap chain images dot data. One last thing, store the data format in the extent we've chosen for the swap chain images in the member variables. We'll need them in future chapters. So when it says image type, I'm curious, does that mean like PNG, JPEG, or something like that? Or is this like actually just like a whole different image format? And like, well, actually no, they specified earlier that's the sRGB stuff. So I guess I guess it kind of is, kind of isn't. Like, it is an image data type, but it's not like it's not an archival format like JPEG or PNG, where it's like compression and a bunch of stuff, right? It's just like raw data is what I'm sniffing. Let's see. One last thing. So the format and the extent we chose for the swap chain images and member variables. We'll do them for future chapters. VK swap chain chronos, swap chain, standard vector of type VK image, swap chain images, VK format, swap chain image format, and VK extent 2D, swap chain image extent, ellipses. Swap chain image format is equal to surface format dot format. Swap chain extent is equal to extent. Now that we have a set of images that can now be drawn onto and presented to the window, in the next chapter we'll begin to cover how we can set these images as render targets, and we can start looking for actual graphics pipeline and draw commands. Yay! Let's try run this. So boink boink boink. Paste it in there. Save it. We're gonna back out. We're gonna instead run VK test. Oh, not that. We're going to instead go to the make file. I'll probably go through here on my own time and just add a bunch of comments to try and like reinterpret everything, because it is like basically assigned reading, right? So let's try the whole make. Cool. And then we'll try do the same thing from before. Let's see. Yeah. PP extension names is null, but the extension count is greater than 0, so failed to create instance. Yeah. Okay. So that's still erroring, which is fine, and then we'll do one more little chapter because this chapter is very short from what I recall. Yeah, that one's fine. So let's see. To use any VK image, including those including those in the swap chain and in the render pipeline, we have to create a VK image view object. The image view is quite literally a view into an image. It describes how to access the image and which part of the image to access. For example, if it should be treated as a 2D depth texture without any mapping levels. In this chapter, we'll write a create image views function that creates a basic image for every image in the swap chain so that we can use them as color targets later on. First, add a class member to store the image views on. Standard vector of type VK image views, swap chain image views. Create the image views functions and call it right after the swap chain creation. So create swap chain, create image views, and that's in the init function. First thing we do is resize the list to fit all of the image views we'll be creating. So then swap chain image views dot resize swap chain images dot size. For the next loop, next the set up the loop that iterates over all the swap chain images. So for size ti is equal to 0, I is less than swap chain images dot size, I plus plus. The parameters for the image creation are specified in the VK view creation info structure. The first parameters are straightforward. VK image view create info create info. Create info dot s type VK structure type image view create info. Create info image swap chain images of the index of I. Let's see, the view type and formats field specify how the image data should be interpreted. The view type parameter allows you to treat images as 1D textures, 2D textures, 3D textures, and cube maps. VK info dot view type is equal to VK image view type 2D. Create info dot format is equal to swap chain image format. The components field allows you to swizzle the color channels around. For example, you can map all the channels to the red channel for a monochrome texture. You can also map all the constant values of 0 and 1 to a channel. In our case, we'll stick to a default mapping. So create info components.r equals vk component swizzle identity. And then same thing for components.g, components.b, and components.a. The sub resource range field describes what the image's purpose is and what part of the image should be accessed. Our images will be used as a color targets without any MIP mapping levels or multiple layers. So what's a MIP mapping? Because I don't actually know what a MIP mapping is. I was going to hope they kind of explain it, but they don't seem to explain it. So let's see. MIP mapping is a computer graphics suite that uses multiple versions of an image. Multiple versions. I don't know why I'm reading the fucking AI overview. In computer graphics, a MIP map, MIP being an acronym of the Latin phrase multum in parvo, meaning much and little, is a pre-calculated optimized sequence of images, each of which has an image resolution which is a factor of 2 smaller than the previous. Their use is known as MIP mapping. They're intended to increase rendering speed and reduce aliasing artifacts. A high-resolution MIP map image is used for high-density samples, such as objects close to the camera, and lower-resolution images are used for objects further away. Okay, so it's basically just saying, like, hey, if you don't have, like, anything up close, then, you know, shoot off. Shoot off to a smaller size. Let's see, the sub-resource range field describes what an image's purpose is and what part of the image should be accessed. Our images will be used as color targets without any mapping levels or multiple layers. So, create info.subresource range, that's going to be repeated a few times. Dot aspect mask is equal to VK image aspect color bit. Dot base MIP level is equal to 0. Dot level count is equal to 1. Dot base array layer is equal to 0. And then dot layer count is equal to 1. That's the end of the repeats. If you're working on a stereographic 3D application, you want to create a swap chain with multiple layers. You can, you can then create multiple image views for each image, representing the views for left and right eyes by accessing different layers. Create the image view is now a matter of calling VK create image view. So if VK create image view device, the address of create info, null pointer, and the address of swap chain image views with the index of I is equal to VK success. Or sorry, it's not equal to VK success, and throw standard runtime error, failed to create image views. Let's see. Unlike images, the image views were explicitly created by us, so we need to add a similar loop by destroying them again at the end of the program. So then clean up for auto image view, swap chain image views, VK destroy image views, device image view, and null pointer. And then for the lulz, let's open this, let's copy it, let's paste it, and see if it runs, or let's see if I have to do a lot of debugging stuff on my own time. So let's go do. We will save that. We'll run the quick make, and then we'll run it. Oh, I don't see any errors now. So it does work. Okay, cool. So yeah, so I'll have to go through here, and I'm gonna comment it up and a bunch of stuff like that later. I'm feeling quite burnt out. I have to be in bed in about an hour because of work stuff tomorrow, so I'm gonna pause here. So hey, thanks everybody for watching. Sorry if this was a bit of a boring stream. The plan for next week, I suppose, to fill it out is I think next weekend might be a double feature game weekend. Because I want to finish Super Mario 64 to get that wrapped up, and then I also want to finish And then I also want to finish gosh, what's the name of it? I want to also finish Deltarune Chapter 4, because I have those two kind of game series kind of hanging in like odds and ends, right? So what I would like to do is I would like to be able to get those wrapped up, and then once those are wrapped up, then I can move on to doing, bigger, bolder things, right? Because I do really want to get back involved with the with the Godot game dev stuff, because I have some ideas that I've been playing with. Some of them seem promising, so I'm kind of playing with them on my own time. And there's some other stuff I want to do as well in the meantime before then. So hey, here's to hoping all that can be done and accessible and whatever. So hey, thanks everybody so much for watching. We're making our way through here slowly. Hopefully we'll by part 6 we'll be able to actually have this done. So here's to hoping. Once again, thank you everybody. Hope you enjoyed the stream. Like the video if you liked it. Dislike it if you didn't like it. And I'll catch you all later. So bye bye. Have a good time. I catch you later. Goodbye. Bye.